sort of just very fundamentally, I think we have to be prepared for a world in which there will be millions of chains. Not necessarily millions of rollups that all checkpoint on the same thing, but we'll have to be prepared, like if you want to see true mass adoption, that like every city, every government, every community is going to run their own systems. And so the big question, the big sort of open design is how do we connect many of these heterogeneous trust environments together into something that doesn't enforce yet another level of abstraction, so like that doesn't enforce another level of trust, so we can't have a single chain to rule them all, I think, because most governments won't play with this, and like most communities will want to have some level of sovereignty. But like, how do we allow developers and users to experience homogeneous application architectures and homogeneous applications that can roam on a heterogeneous trust model with things like privacy as well. And so I'll briefly speak about this. Yeah, time was running. Great. So today's talk is called From Virtual Machine to Intent Machine. And just very briefly, I'm going to skip sort of through the first beginning of the slides a little bit. Just very briefly, how did we get here? What has this evolution looked like so far? So we've seen currently one large phase shift, roughly from Bitcoin to Ethereum, and we really moved from Bitcoin, these very transaction-centric systems, to Ethereum, which are very much a VM-centric system, right? And I mean, earlier and again on the panel, we spoke about how we had many Bitcoin and Bitcoin-like systems over time, and then all of a sudden we had Ethereum and Ethereum-like systems, and really, I think this can't be the end of the road in terms of fundamental architecture that developers use. And so today I'm talking about, intent machines. So sort of like moving from transaction-centric systems to VM-centric systems to intent-centric systems. Because fundamentally they're just a better abstraction for what most people currently actually have, right? Like when you think about the abstraction for Bitcoin was always, well, I would like to go to a store and I would like to buy some milk and here's some Bitcoin. Most users don't have this, which was clearly shown on Ethereum, because most people actually have something that is more akin to like, I have A for B and I'm trying to figure out who else is B for A. And I actually don't mind whether there's one counterparty or many counterparties. I just have sort of my specific intent and I would like to have this solved. And here I'm talking about Anoma, which is really a new design for intent machine architecture that gets deployed on existing virtual machines. So this is, I think, very important to understand. This is not a it's not to replace Bitcoin or Ethereum. It is more the intent machine, the Anoma resource machine is something that you can deploy to wherever your users or your developers would like to be. So like if this is Ethereum mainnet, you can do it there. If this is on your favorite rollup, it's there. If this is on some permissioned government chain, it could be there as well. Yes, so TLDR, in Bitcoin, we authorize transactions. In Ethereum, we really authorize execution traces, these are fundamental virtual machine-centric things. We describe sort of the compute steps we'd like to take rather than the specific end states that we'd like to achieve. And then in Anoma, we authorize end states. So you don't have to define, call this opcode, call that opcode in order to sort of you do some compute over some state, but rather you define, I currently have state A and I'd like to be in state B, and someone else please figure out the compute. Which is, I think, honestly, the only reasonable model of these systems that I can explain to my parents. Because if I have to explain to my parents, you have to like audit every single opcode in the transaction that you're signing, they will go, you're crazy. If I'm telling them, well, I currently have like 1 ETH and I'm willing to hold the CryptoKitty if I have 0 ETH, like that's a very understandable mental model that I think normal people can actually sort of like reasonably be expected to follow and understand. Oh, there we go. So yes, Anoma, the first generalized intent, the first design for a generalized intent machine. A lot of people have started talking about intents. When we started thinking about intents at the beginning of Anoma, everyone thought we were crazy because at the time, no one sort of thought about intents, no one knew what an intent was. And currently, when people generally speak about intents, they think about like application-specific intents. For example, a limit order is a very specific kind of intent. Anoma fully generalizes this, and like you can express whatever you want. Like whatever you can write in code, you can express as an intent. This means you can say things like, I would like to do A for B if the weather in Paris is nice, and if the weather in Paris is bad, I would like to do B for A. and I'd like to get a free CryptoKitty kind of thrown in. Whatever you can express in some state on an underlying system and some code that describes sort of the constraints over the state transition, you can express with Anoma. And the even bigger thing is this also generalizes across controller zones, where you can think of controller zones really as what we historically refer to as consensus mechanisms, as in like there's like a rollup has its own controller, the EVM main chain has its own controller, so you can express things. I would like to settle A for B on either Optimism, Arbitrum, Mega ETH, or the Ethereum main chain. So Anoma can live, it's really like an operating system that can live wherever, on whatever underlying execution platform you as a developer or user want to live on. Oh man, I've never experienced latency on HDMI. Interesting. So just briefly, what is a virtual machine? Well, a virtual machine has some specific instruction set, has a program counter, has different layers of memory storage, and it generally runs programs sequentially, right? Like, and the best example we have is the Ethereum virtual machine, but also like the Solana virtual machine. These are all examples of fundamental virtual machines that do some amount of compute. On the other hand, an intent machine takes a batch of intents, computes valid possible state transitions, and then selects one of those according to some criterion to update the system state. We don't have those yet. The first implementation really is the Anoma resource machine, which, interesting enough, it's not exactly an account model. It's also not exactly a UTXO model. It allows you to, so it functions a little bit like a UTXO model, but with complex states attached to it. And it allows you to be very clever about state layout. And I think sort of like, if you take one thing away from this talk, is that whenever you think about either scaling or decentralization or cost or speed, you need to think about state. Compute is not the hard problem. Compute is like, scaling compute is trivial. Scaling state and figuring out state co-location, that is the very, very difficult part that actually matters to decentralization, right? Like fundamentally, most state does not have to be co-located when you think about it. Like if I'm doing a transaction in Switzerland and you're doing a transaction in Singapore, there's zero reason to get global consensus over these state updates. Like they do not have to be co-located with each other. However, if we're all in the same room and we'd like to do lots of high-speed trading in this room, then our state should be co-located. And so like Anoma thinks a lot, and the Anoma resource machine thinks a lot around state co-location and what does state co-location mean to decentralization. Yes. So it's a new paradigm for infrastructure. So we evolved from transaction-centric and VM-centric design to more of an application and intent-centric design. This generally means that as a builder, you get fully generalized intents, you get very cool things such as decentralized counterparty discovery, because really like one of the very hard things is how do you do counterparty discovery in a decentralized way? Sort of Uniswap AMMs are the poor man's way of doing counterparty discovery, which is actually incredibly smart, where we use the chain to be the counterparty discovery point. However, it makes no sense when you think about it from a cost perspective that we should like use consensus to do counterparty discovery. It is much better if we can do decentralized counterparty discovery on a P2P level, and Anoma implements this on a P2P gossip stack. It also helps with distributed solving, so you have composable solving, for example, which means that I can do, like if I have an intent from A to B and someone else has B to C, a solver can pick this up and collapse this into A to C. So in that sense, I mean, so if you think a little bit about the problem of rollups and sort of like L2s, you very quickly realize that rollups are really just intent-centric systems because there's some chain of intents that a sequencer then collapses into a single state transition, either by providing a signature, sort of in an optimistic case, or a ZK proof in a validity case. Yes, and you also, with Anoma, with the Anoma resource machine, you get some novel properties such as information flow control, which is really, to say another word for privacy guarantees, because it is not, there's no difference in terms of the application development. Whether something is private or not is really just a function of whether a user decides to attach a zero-knowledge proof to their state update. Like if a user decides that they would like to do A for B but privately, then they just attach a zero-knowledge proof instead of a plain text signature, and the entire system works the same way. So you, as a developer, you can build, for example, an order book exchange, which can be completely privacy preserving depending on whether your users want to be privacy preserving. And you don't have to split the different, like you don't have to split the world between sort of the transparent as well as the privacy preserving side. By the way, if you want to talk about how you do like order matching in a privacy-preserving manner, this is hard. And if you want to coordinate with someone, we can talk about this afterwards. But the TLDR is, if you want to coordinate with someone, like I want to do A for B, I have to announce some of this intention to the world. Otherwise, it's going to be very difficult for me to find a counterparty with whom to do it. Yes, and as users, as I was saying in the beginning, you move away from having to think about, this is my, like, I would just like to execute a complete state transition on chain, because really a transaction is something I can update the system state. However, as a user, I generally don't have a like thing that wants to update the system state. I have a sort of partial, I have an intent that I would like some other people to coordinate with, but I don't actually care who these people are, that then updates the system state. So as a result, like the current, this is, I think this is why I think of this as really a new paradigm, because it moves us, it sort of like furthers what users and developers can do with these systems. It like, rather than just sending, here's a transaction, please update the system state, we have sort of the pre-step. And the nice thing is we don't have to build this pre-step in an ad hoc fashion where everyone relies on the same single server to do all the pre-step for you. We can rather build in a decentralized fashion. No, I didn't. So yeah, Anoma is a universal intent machine. And the important thing, Anoma is a universal intent machine for Ethereum. Really, and I really want to highlight this point, because I think not enough people appreciate this. There's no Anoma chain that you must interact with. Anoma is a protocol definition. It's a protocol standard. It's a distributed operating system for decentralized application. Your operating system you can run this on whatever specific execution environment you want to run this on. This could be on the EVM main chain, this could be on a rollup, this could be on Solana. There's no chain that you must interact with, that you must send your intents to. And I will go later on through why you should be very careful with intermediaries. But really, it's a higher level of abstraction that as a developer I can then use. And as a user, I can then decide, well, there's this cool application, the operating system is implemented on these 3 systems. Today, I would like to use system 1, tomorrow I'd like to use system 2, and I don't have to fundamentally switch my application. I don't have to fundamentally switch my RPC endpoints. It is all just a uniform stack where in the intent itself, you decide on which specific settlement you'd like to execute this. Yeah, so this can even be on like an eigenlayer AVS. I actually don't mind. Like I think, so fundamentally which security model people want to use is up to them. Like Anoma is just there to provide a very good high-level abstraction for people to build applications against, so that applications and users can roam into whatever security domain they want to roam. And like, I personally like to think of this like the example of my phone. It's very nice that historically we've managed to agree on like a telephone standard and a networking protocol standard, so that my phone that I bought in Switzerland still works in Singapore. That to me is magic. And I would like to get the same sort of capabilities into the blockchain industry, where my application that currently works in Ethereum can just roam and works on Solana. Like we don't have to rebuild every single application for every single execution environment that we may want to care about in the future. Always playing these. Yes, so Anoma is also an intent machine for Solana, for Cosmos, for Polkadot, for your local government chain. I don't actually mind. And this comes to this important point. Anoma is an interface, it's not an intermediary. And I think we don't think about this enough in this space. I think we are very happy to accept intermediaries if these intermediaries give us sort of some notional guarantees that we don't have to trust them. Oh, damn, I have 3 minutes. Okay, cool. I will hurry up a little bit. So intermediaries are generally actors on the network. Even chains are intermediaries. Like we should not kid ourselves. Like when we think about chain abstraction, for example, yeah, we're just adding yet another intermediary. This is like, we're just like layering on top the security on each other and hope that nothing breaks in the middle. Generally, these have privileged positions. They can extract rent. They introduce additional security assumptions. And importantly, they add unnecessary latency. And I want everyone to like think about this for a sec. If you want to do the fastest possible trading, you are very latency sensitive. And ideally, you should trade with people as locally as possible, because nothing ever will beat LAN connections in this room. Like no chain in the world, like Solana, can never be faster than this. If we can do local settlement, we will always be faster than going via some intermediary that has to route our state. Yeah, so for example, in Ethereum, currently many bridges in our ecosystem are intermediaries, if you honestly look at it. On the other hand, you have interfaces, which are just protocols, which translate some semantics to an underlying compute platform. And this is really what Anoma is. It is like you can copy the code, you can read the research, you can implement it yourself as an operating system. It's effectively a distributed operating system that anyone is free to use on whichever system you'd like to use it, but connected via a P2P stack so if you form a distributed operating system. In the real world, we actually have a good example for this, which is TCP/IP. And it was designed very well for this. Yeah, there's no Anoma chain to which one must send intents. This would make no sense. I'm very skeptical of everyone that says just like send your thing to my thing. We've tried this before. It was called the Polkadot relay chain. Didn't work then. It won't work now. It's 15 seconds. There's a bunch of underlying research is linked here on the Ethereum research post that my co-founder Chris wrote. It's a dense read, but it's a very good read. I think he's working on an updated version actually at the moment. Okay, I see no 2 phones, great. All right. Fundamentally, Anoma is scale-free, as in you get local and global scalability without losing interoperability. And what I mean by scale-free, you can deploy it in whatever scale you want. It means that you can have local instances that sort of settle locally that are still interoperable with the global Anoma deployment running on Ethereum. It means that I can like very easily roam between global Ethereum to global Solana, for example, where I roam between 2 different security models. Or if I want to do lots of local things in Switzerland, I can roam down to my local instance. I think this kind of scale-free network design is the only reasonable way to actually achieve global scale for these systems. There's very little we can do with regards to if we want to have global consensus on something, we will always be slower than something that's locally sovereign. The other reason I think, at different times I've asked people like who here is in favor of a one world government, and very few people seem to be in favor of this. So we should not be designing this industry around the idea that we want to have a single global security model. We should rather design it to have lots of independent local security models that can all interoperate and compose with each other. Perfect, yes. So TLDR, we're moving from transaction-centric systems to VMs to intent machines. It is not VMs replace IAMs. It's not that the intent machines replace the virtual machines. They are fundamentally compatible with each other. And interesting enough, without global Ethereum, without the EVM, there would be no place to run the intent machine. I think this is very important to understand. This is a high level of abstraction that gives developers more functionality. This is not there to replace existing systems. It is really, but I think in the earlier panel, it was discussed like, well, all these things, like all these things currently kind of look like Ethereum main chain, and yeah, I agree. Like I think spend a couple of years not innovating on what is possible to do for developers. And I think Anoma, like we should be really thinking like, how do we improve the expressivity of our systems rather than like running the same system in a slightly different color at a slightly different speed. Yeah, the new IAM paradigm. It's a universal intent machine for Ethereum, Solana, Cosmos, any other sovereign chain. This is really, because it's a fundamental user choice. Where do users want to settle? And so like if everyone for some reason wants to run on the single one world government yuan chain, I mean, like I'm not in favor of this future, but there's also very little, like I'm happy to at least write open source software that gives them a good developer experience while doing so. And yeah, we should care about interfaces, not intermediaries. I think. And scale-free, yes. If you'd like to know more, there is a bunch of underlying research that backs all of the distributed operating system and how this works practically at art.anoma.net. Yeah, thank you very much.